dear friends, welcome to my channel. Today's discussions is GATE 2021. Let En such that n equals to 1, 2, 3 be a orthonormal basis of a complex Hilbert space H, and consider the following statements. Okay, there exists a bounded linear functional f such that H tends to C such that f e n is equal to 1 by n for n equals to 1 comma 2 comma 3 etc, and there exists a bounded linear functional g such that H tends to C such that g e n equals to 1 by root over n for n equals to 1 comma 2 comma 3 up to infinity. So a, both P and Q are true. P is true and Q is false. P is false and Q is true. Both P and Q are false. Now friends, to solve this kind of problem, we need to know Bessel's inequality and range representations theorem, because they both are included in functional analysis problem. So Bessel's inequality, friends, you have to know that let H be a Hilbert space, and suppose E1, E2, E3 is an orthonormal sequence in H. Then for any x in capital H, we have k equals to 1 to infinity ax ek whole square less than equals to norm of x whole square. Raise representations theorem. Let H be a Hilbert space if f be a continuous linear functional on H, then there exists a unique vector v in H such that fx is equal to x comma v and norm of f is equal to norm of v, means continuous linear functional on H. Okay, so friends, let's see the questions. Linear functional f such that H tends to C such that f en equals to 1 by n. Okay, so f such that H, okay, this is the countable. Okay, you can say it is countable and it is bounded. So fen equals to 1 by root over, yeah, fn is equal to fen equals to root over 1 by root over n. Yeah, this option Q. Okay, we see option Q. For option Q, there exists a bounded linear functional. Okay, linear functional, it is bounded. Okay, bounded linear functional g such that f en f, yeah, otherwise you can write it is also, you can write it is g. Okay, g such that n. Okay, no problem. v gx x equals to x comma x belongs to capital H. Okay, no problem. Next is that according to the questions, by the Bessel's inequality. Okay, Bessel's inequality summation n equals to 1 to infinity v e n whole square is equal to summation norm of v whole square. Okay, so this formula is the Bessel's inequality where E1, E2, where En is orthonormal basis. Okay, E1 is orthonormal. So this equation is equal to summation n equal en written as gx means g 1 by root over n gen, okay, gen, and gen is equal to this and equals to can be written as norm of v whole square, okay. So by the way, this is that sum to infinity 1 by n less than equals to norm of v whole square, which is finite. It is say finite, but it is not finite because we know this is divergent series. Divergent. So divergent series is not finite. So my first option, that q is false. So P and Q both are true. This is not possible. P is true, Q is false. This is, and Q is P is false, Q is true. This two possible. Now let us check for P. P case is 1 by n. Same factor, friends. That Gx is equal to Gx. We can Gx or otherwise Fx. Fx equals to summation n equals to 1 to infinity x into 1 by n, and norm of fx is equal to k norm of x, okay, k norm of x. Which formula I apply, friends? I apply Bessel's inequality, okay, Bessel's inequality I apply, and norm of fx, it can be written as summation n equals to 1 to infinity x en x comma en into 1 by n, in norm equals to summation n equals to 1 to infinity norm n, okay. This can be written this way by the Cauchy sequence, the Cauchy series. It can be written this way: Cauchy inequality, okay, Cauchy inequality root over summation n equals to this value is equals to a norm of x, okay. So friends, we see the same way we get 1 by n square. 1 by n square is equal to convergent. So as it is convergent, we get summation 1 by n square is equal to less than equals to norm of x. So n equals to 1 to infinity. So it is possible because this is convergent, okay. So P is true and option D is wrong, because there exists a bound that Fen is equal to 1 by n for n equals to 1, 2, 3. This option is correct. Thanks for watching.